we're going to go ahead and take a look at number 43 from section 3.3, polynomial and other functions. 43 is going to be f of x is equal to x squared minus 4x plus 4. And the directions for this problem are to state the open intervals where each function is increasing, decreasing, or constant. So your best approach for number 43 is to go ahead and graph it. Okay. Visually, you'll be able to see what is going on much more clearly than just by looking at the polynomial. Okay, so we'll go ahead and note that. First off, we can go ahead and access what we have worked with regards to quadratic functions. So we know what shape we're going to be getting just by looking at the degree. Now what we can go ahead and do is we can calculate the vertex. And we know that in order to find the x value for the vertex, so let me kind of label this so we keep all of our work organized. We know that we can get that by finding negative b all over 2a. So negative 4, because that's what our b is, and then 2 times 1, because that's the coefficient that we have out in front. So if we were to clean this up, this would be 4 over 2, or simply 2. So in order to find the y value for our vertex, we would plug in 2 everywhere that we see x. And that ends up being 0. So our vertex is going to be at 2, 0. Again, that's where all that information is going to be fed in. So 2, 0 is going to be located right here. And really all that we need to do is do a rough sketch, because we're not really being asked to find any sort of x-intercepts or y-intercepts. You can most definitely do that if you wish, or if you feel like it will help you accurately answer this question. But again, in my case, what I'm kind of thinking is, well, I know that because the coefficient out in front of the x squared is a positive, I just need to know what direction my parabola is going to open up. So what I have here on the screen is actually a very rough sketch. I know where the vertex is going to be plotted on the coordinate plane, and I also know what direction the parabola is going to be opening. That is enough information for me to answer the question. I just want to know, where is this function decreasing, where is it increasing, and where is it constant? So let's kind of note those things down so that I have a place to jot down these notes. Okay, so where is it decreasing? Well, we want to read our function from left to right like we would a sentence. So we want to actually start from the left. And it looks like as I'm coming down this way, as I'm following here, I am decreasing. Don't let the arrowhead on the far left fool you. It's not telling you to just follow it upward, but it's more or less indicating to a reader that the line will continue off of the page indefinitely. Okay, so again, if we're following through, it looks like I am decreasing from negative infinity to 2. Okay. Please note that the intervals that we're talking about, we are referring to the x values. Okay, so we are referring to what x values we're using that will result in this function to decrease. Then if we continue, so from 2 on up, meaning the x values that we use from 2 to infinity, that's going to generate the portion of the function that is increasing. So then the next question is, well, where are we experiencing something that's constant? There actually isn't anything. So there is no interval where we're seeing the function take on a constant rate. Okay? So in order for there to be a constant rate, we would visually need to see on our graph some sort of flat horizontal line. And with a parabola, we don't have that. Okay? So hopefully this answers the question to your liking. If you have any additional questions, please let me know. I'd be more than happy to go over them with you.